Alright guys, here we are. This video is recommended by Luke Strasser, and we're going to be doing the cam for the Rick Bork Mandrel in this video. This video has been a challenge for me. I've run into roadblock after roadblock, I tell you. Trying to get this running on different computers, practicing, oh, it's been bad, I tell you. So let's get started. And here we are. We got the mandrel. You can see we already have our model done. We're not going to be doing any CAD work in this. This is going to be all CAM. So we can take our model and flip it all over around and look at it. But what we need to do is come over here to where it says design. And we're going to move down and select manufacture. So there we have it. We're in the CAM workspace now. They call it manufacture now. So let's get our model squared up. The first thing we need to do is come in and make a new setup. Come up here, choose new setup. So we need to come over here and make sure this is on mill turn. And we need to select our Z-axis, which it appears it's already selected the Z-axis for us. Move that. It's going to choose a face. And you'll see over here that the Z is going in this direction. That's exactly where we want it. Looks like our X is where we need it to be. Everything looks good there. Now we need to set our stock. Fixed size cylinder. Our stock diameter is going to be 1 1/8. 1.125. Our length, we're just going to arbitrarily choose 4 inches so we have plenty of material working with. And I want to change it from offset from front. The last thing, we'll click on the post-process tab and we're going to give it a name. I'm just going to call this RB1. Just something that I can remember. And then click OK. So now we have our stock defined, our setup's ready to go. We can come over here and click on setup. This is just a name. I'm going to rename this side 1. Now that we have that, now we can start our actual real cam work. We're going to come up here off the toolbar and click turn the face. And this computer is terribly slow. So we come in here, select a tool. I'm going to be using the WNMG 332 tool. Now we want to go through, look at all of our different settings. Definitely don't want a max speed of 5,000 RPM. Let's change that to 950. We're going to use a cutting feed rate of 10 thousandths per revolution. Next, we're going to look at our geometry. I need to rotate this model a little bit so the X is in the right place. So we don't need an offset. We're good to go there. Our diameters, we can drag this in just a little bit. We don't need all that extra clearance. Nothing really to do here. Everything looks good here, so we're going to go ahead and click OK. And our tool path is complete. We know that by we have a green check mark here. I like to save often. And just for fun, let's go ahead and simulate that so you can see what we just did. I'm just going to come down here and hit the play button. You see our tool moves in, does a facing cut, and moves out. It's exactly what we want. So the next thing we need to do is our roughing passes. We're going to come up here, click on our tool for turning profile roughing. It's already selected the WMG 332 tool. That's exactly what I want. Tool orientation is correct. Definitely need to slow that down to 950. I do want to keep this 10 thousandths cut at feed rate. We're going to select where our area that we want this tool to be able to work. This looks good. Same as before, we can adjust our radius, so we don't really need to waste any time. I want to come down to this grooving and turn off grooving. We come down here and adjust our depth of cut. I want to change that to 100 thousandths. Our stock to leave, let's say in 4 thousandths. I want to change that to 10 thousandths on the X, 5 thousandths on the Z. Just going to do a quick once over of this last tab here, and I don't see anything out of place. We'll hit OK, and it's going to come over here and it's going to calculate our tool path for us. And like I said, this computer is terribly slow. That should have gone by faster. Just like before, let's simulate that. We'll give you guys an idea of what's going to happen. Hit our play button. You can see that it's simulating exactly what's going to happen on the machine. I'm running this simulation pretty slow to make it easier for you to see, and that looks good to me. So that did our roughing passes. Now we need to do a finishing pass. So I'm going to come over here, right click on the roughing and create a derived operation, turning profile finishing. It's already selected our tool again for us. Now we would have an option. In fact, let's just go ahead and do that. Let's go ahead and select the tool here. We'll come to our tool library, and I want to choose tool number 3, the VCMT 332. Now we've selected that tool. I think I want to maybe slow this surface speed down just a bit. Take that down to 600. We're on feet per revolution and 5 thousandths feet per revolution. It's exactly what I want. And everything looks good here. In fact, it copied the tool path from the last operation, from that roughing operation. It should have copied this radius too. Passes, we're only going to have one pass. Down here, stock to leave, we are not going to leave any stock, so we want this unchecked. In this last tab, everything looks good. We're going to hit OK. Our tool path is made, and let's simulate it again. Come down here, hit the play button. There you have a finishing pass. I'm going to go ahead and save that. The last thing we need to do is turning and grooving. We're going to come in here, select a tool, we're going to choose our parting grooving tool. It is 3/16 or 187.5 thousandths wide. We'll go ahead and select that one. Select. Outside grooving is correct. Let me change this 5,000. I don't want this going over 900. I don't know about other guys, but when I run grooving parting tools, I try to play it pretty conservative and run a 2 thousandths per revolution feed rate. Now we need to come in here and adjust our cutting area. We're going to start with that. Offset from front, let's adjust that a little bit. I'm going to change that to 1 9/16. And then our offset from the back, let's offset that 3/16 of an inch. Make that minus 3/16 of an inch. Just like before, we're going to bring our radius down. And of course, it's not going to agree with me, so I can look like a fool. Or retract. I don't know why that's on negative. Let's set that to just an extra decimal point in there. Maybe that's a problem. Not sure why it's giving me an issue with that offset. There we go. All that looks good. We need to look at our passes real close. I want to change our up and down direction to only down. We can adjust our step over. We'll say 150 thousandths. Finish feed rate, rough passes. Maximum grooving. Let's make that 150 thousandths. And I'm just about going to bet this isn't going to work, and we're going to have to come back and figure out what's wrong with it, which that's okay too. It's all part of the learning. Let's hit OK and see what it comes up with for us. So I can tell you right away, I don't like what this looks like. I'm going to simulate it, and you can see what I don't like about it. Pay attention right in this area right here where our mouse cursor is. You notice the tool turned red. That's telling me there's a collision. So we don't want that. So we need to go back in and edit to see what we can change and make that better. So we're going to go back into our passes. Let's try changing this and see what happens for us. It looks exactly the same, so that's not what I want. Back in and edit. Let's turn off the finishing pass and see what it does. Just going to kind of explore different options. Alright. So here we have it. I'm going to save. I like the idea of having this little groove right here. Now let's create another derived operation. Turning a groove. Now everything's going to be the same again. Go into our passes. Let's turn off our roughing pass this time. Give it a go. That looks good. Let's simulate it. That looks good. So by doing it this way, we created a little bit of working room in here for the tool to come in and do this backside profile. The reason why I want to go ahead and do this profile now instead of after we flip it over and run the other side is so that our area here for our disc stays concentric to our shank that goes up inside of the die grinder tool. So that pretty much gets us there, but we need to be able to cut it off. Let's see if by adjusting some things we can modify that tool path. See if it'll cut it off. It looks like it is going to. So let's simulate that. Coming across, does our profile, and cuts it off. That's exactly what we need. And just for fun, how about we see if we can adjust this to have the tool come in and take off that little bit of a nub it's leaving. So let's edit. Oh, it's on radii. Here we go. Distance to cut below center. Let's make that 0.025. And OK. Now you'll see we don't have that little nub anymore. Let's simulate it. hit the play. That gives us our rough shape. And just for fun, let's come up here, select side 1, simulate the whole entire part instead of just one operation at a time. Speed it up just a tad. It's also going to put each operation into a different color. There you have it. I'm going to go ahead and close. So it's saying 1 second down here in the corner for the facing operation, 11 seconds for the roughing, 4 seconds for the finishing, 8 seconds for the rough groove, and 12 seconds for the finish groove. I'm going to take a wild guess and just tell you that that's way too fast. It's going to run a lot slower than that when we go to try to really run the part. But that gets us through side 1. We'll get this put together. Let's save this. And now we need to post-process. And this will actually write the real G code that the machine will use. I need to choose the correct machine. We have Akuma turning. And we need to change our output folder. So let's go ahead and make a new folder. Let's do it this way. Come into our cam. Create a new folder. Just call this the RB Mandrel. I'm going to select the folder. Go ahead and call this RB1. I'm just kind of going over these options. These are kind of machine specific options over here. Looks good. And we'll just go ahead and hit enter. And our OK button is off the screen. That's quite embarrassing. There we go. It took it. Now, in the free version of Fusion 360, unfortunately, we have to post out each one of these and then manually re-edit them all. And I don't want to put you through that agony. So I think we're going to cut the video here. I hope you guys picked up some new knowledge. Get with me and down in the comments and let me know if you want to see me do the CAD cam on the, or just the cam actually, on the other side where we face it, drill it, and tap it for the retainer, and then also the cam for the retaining washer, or if we should just drop it and just go to making parts. You guys got to let me know. So I think that's going to do it for this one. I look forward to your comments. Thanks for watching. Keep on coming back for more.